Hello, welcome back to my YouTube channel. I'm Pradnya. In this video, I will explain the material about mathematical logic. Mathematics is a science that has a very broad scope. Mathematics is not just the study of numbers and calculation. However, there are things to learn in mathematics other than arithmetic, one of the logic of mathematics. Mathematical logic will provide a basis for how we can draw conclusion. The things in mathematical logic that we will study this time include statement, negation, the relationship between two or more sentences, and how to draw conclusion from the sentence given. The first is statement. Basically, a statement is a sentence that is true or false but not. In mathematical logic, there are two types of statement, namely closed statement and open statement. Closed statement is a statement whose truth value can be ascertained, while an open statement is a statement whose truth value cannot be ascertained. Example: 8 plus 2 equals 10 is a closed statement that is true. 4 multiplied by 6 equals 20 is a closed statement that is false. 5a plus 10 equals 40 is an open statement because it must be proven its truth. The second is denial or negation. Denial or negation is defined as a statement that has a truth value that is contrary to the original statement. The following is a table of truth denials. If a question or P is true, then negation will be wrong, vice versa. For example, P, all students pass the test. Negation of P, there are students who do not pass the test. The third is about compound statement. Compound statement in mathematical logic consists of disjunction, conjunction, implication, and be-implication. Disjunction. Disjunction is a compound statement with the conjunction or. So, the notation on the slide reads P or Q. On the slide is a true table of disjunction. From the table on the slide, it can be concluded that the concept of disjunction will be wrong if both questions are wrong. For example, P wolves are mammals. Statement is true. Q whales are herbivores. Statement is false. Then P or Q, wolves are mammals or herbivores. Statement is true. Conjunction. A conjunction is a compound statement with the conjunction and. So, the notation on the slide reads P and Q. On the slide is a true table of conjunction. From the table on the slide, it can be concluded that the conjunction concept will be true if and only if both statements are true. For example, P, 3 is a prime number, statement is true. Q, 3 is an odd number, statement is true. Then, P and Q, 3 are prime and odd number, statement is true. Implication. Implication is a compound statement with the conjunction if blank 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 then. So, the notation of implication is on the slide, read if P then Q. On the slide is a truth table of implication. From the table on the slide, it can be concluded that the implication concept will be false if and only if the cause is true but the effect is false. Besides that, the implication is true. For example, P. Andy study with the Google Meet application. Statement is true. Q. Andy can study anywhere. Statement is true. If P then Q, if Andy learns with the Google Meet application, then Andy can study anywhere. Statement is true. B implication. B implication is a compound statement with the conjunction blank 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 if and only if blank blank blank. So, the notation of B implication is on the slide. Read P if and only if Q. On the slide is a truth table of B implication. From the truth table, we can observe that the B implication will be true if the cause and effects are the same. Either both are true or both are false. For example, P 30 multiplied by 2 equals 60 statement is true. Q 60 is an odd number statement is false. Then the implication of P and Q 30 multiplied by 2 equals 60 if and only if 60 is an odd number. Statement is false. That's all of me about mathematical logic. I apologize if I make a mistake. Thank you and see you. Bye bye.